Hello everyone, I am Ankit Kulkarni. My project topic is Feature Engineering and Predictive Modeling on Retail Dataset to Forecast Sales Outcomes. This project is done for the course Pattern Recognition. Sales is a vital component in any business. Sales forecasting is a process used to predict future performance by utilizing past and present sales data. The practicality sales forecasting delivers increases our understanding of the marketplace and helps develop and improve strategic plans. It helps make statistically sound judgments. Um, in the case of new businesses, companies have to prove the viability of their business plan by showcasing their growth prospects and sales estimations to acquire the investment necessary to set up the establishment. It would be crucial to know which season is the slowest in terms of sales for a store so that money spent on maintaining the inventory could be controlled in that period. Now, to steer a company in the right direction, sales estimates play a pivotal role. Accurate sales forecasting can help to track data to gain insight into areas where improvements can be made. Sales forecasts helps in sales planning to the sales representatives. It gives a good estimate of the demand for the products the business is selling. Accurate sales forecasts help companies to better manage their inventory, avoiding both overstock and stockout situations, while also helping to keep a better control over supply chain. It also makes predicting company revenue and profit easier. Sales forecast helps marketing team to give promotional offers if the sales forecast is weak in that period. In order to not lose potential customers to competitors, it would be astute to double the workforce and expenditure on the advertising campaigns if there is a prediction of robust growth in the holiday period. Future sales are affected by multiple factors like changing fashions and trends, employee turnover, economic downturns, manufacturer recalls, price change in raw materials, changing trends, etc., making it extremely challenging to accurately predict sales. The project aims at performing hypothesis generation, data exploration, data cleaning, feature engineering on the Big Mart sales data to build predictive models to forecast the sales of every product in a specific outlet. The Big Mart dataset used is from 2013 and contains information of more than 1500 products through 10 different stores in 10 towns all over India. A set of 10 attributes are defined and used for every product in the dataset. The dataset has 10 features, 5 for every product, that is an item, and 4 for every outlet, that is a store, and contains a total of more than 8500 records. The dataset contains more than 1500 unique products and 16 different item types. Now, data exploration involves doing straightforward data examination and coming up with conclusions related to the data. The first step consists of looking at the data and comparing the available data to the hypothesized data. It is a good practice to keep the test and train data together till the feature engineering process is done, as separating them before that would mean repetition of the entire process separately on both the datasets. The second step would be to check what columns in the data set have missing values, as it is a significant challenge in any dataset. The absent values were noticed in the item weight and outlet size columns, which will be imputed in the data cleaning segment. On looking at the simple statistics of the available features, it was observed that item visibility feature has a minimum value of 0, which is not possible as a product displayed in a store cannot have a visibility value of 0. Outlet establishment years is a feature that varies from 1985 to 2009. The values can be more beneficial for analysis if the age of a store can be taken into consideration instead to analyze its impact on sales. For the feature item fact content, it was observed that some products were miscoded and would have to be changed so as to keep all the records uniform. Data cleaning involves imputing the missing values in the columns found in the data exploration phase. Outliers are also treated in the data cleaning phase. Though outlier removal is an important step, it can be skipped because the advanced algorithms used nowadays are invulnerable to the outliers. The two columns with missing values found in the previous step are item weight and outlet size. The item weight was imputed with values of average weight of the particular product, whereas the other column, outlet size, was imputed with value taken from the mode of the outlet size for that kind of store considered. The feature engineering process involves analyzing the features present in the dataset, deciding what features to merge, create, or remove, and then creating or removing the features decided upon in the previous step. Uh, After that, um, we check if the newly created features work well with the model created. If not, improving or modifying the features is done if required. Repeating the process till a set of features utilizing the model the fullest are obtained. After feature engineering is completed, feature selection can be utilized to avoid overfitting. Feature selection is the method of choosing a subset of appropriate predictors and variables to be used in the construction of a predictive model. Feature selection is used for simplification of the models to reduce the number of dimensions, reduce training times, and to reduce the overfitting to improve generalization. The visibility of any item as discussed in a store cannot be 0. Hence we impute the 0 values with average visibility of that product in other stores. Instead of having 16 categories for item type, the categories can be classified into 3 broad categories: food, non-consumable, and drinks. As observed in the previous steps, values are miscoded in the item fact content variable. Another observation states that the non-consumable category created earlier shouldn't have fat content in the column, so it can be converted to non-edible instead. As scikit-learn requires only arithmetic values to work with the data, the nominal variables need to be converted to a numerical type. Also, outlet identifier can be coded to a numerical type as well. This can help check if the sales depend on the stores individually. Similarly, similar processes performed on item fat content, item type, outlet size, and outlet type features. Now, the model building is done by creating 7 models, which include an initial baseline model, linear regression model, ridge regression model, decision tree model, and random forest models with different maximum depths and number of trees. Performance of all the models is calculated using root mean square error. Baseline model is not much of a model but more like an informed guess. A baseline result is the naivest possible forecast. If more advanced methods cannot outperform a simple baseline model, it means that there is work to be done, either redefining the problem or on the data. In the baseline model, the simplest way is to predict the sales values using the overall average of all the sales values. Now, it can also be done using average sales by every item or average sales by every item in specific store type. Predictive analysis is done using regression model, using the linear regression. If there are multiple variables involved, multiple regression is used, as is in the case of this project. And if there's one independent and one dependent variable involved, simple linear regression can be employed. The result obtained is for 80-20 split of train to test data. The RMSE value obtained was 1134 as is shown in the picture for the linear regression model. Ridge regression is useful when the number of features present in a dataset are large. And a large number of features can mean one of two things. Either it might augment the inclination of a model to overfit, or it can cause computational difficulties. Ridge regression performs L2 regularization and helps in reducing model complexity. It is usually used to avoid overfitting. The RMSE value obtained for the ridge regression model was 1136. This was the worst performing model among the six. Decision tree algorithm is mainly used in classification problems. It is useful in case of both continuous and categorical output and input variables. In this method, the sample is fragmented into two or more homogeneous subsets centered on most substantial splitter in the contributing input features. Based on target variable type, there are two types of decision trees: continuous variable decision tree and categorical variable decision tree. Some of the advantages of decision tree are ease of understanding, data cleaning is required in moderation, and extremely valuable in the data exploration phase. The RMSE value obtained for the decision tree model with maximum depth of 15 and was 1065, and RMSE was 1083 for decision tree model with maximum depth of 8. This was the best performing model among the ones implemented. A random forest is an algorithm that is adept at performing both regression and classification. It performs all the essential steps of data exploration. It is a process where a collection of weaker models combine to create a stronger model. For classification, the classification with the most number of votes is chosen, and for regression, average of output of trees is taken into consideration. One of the most important advantages of using random forest model is its ability to handle datasets with very high dimensionality and really large datasets. Now, RMSE value obtained for the random forest model with number of estimators as 200 and maximum depth of 5 was 1083, whereas with number of estimators up to 400 and maximum depth of up to 6, RMSE was reduced to 1077. But still there was not much difference in the RMSE values. From the RMSE numbers seen before, it can be concluded that decision tree model with maximum depth set to 15 produced the best results, whereas the ridge regression model had the worst performance among the 6 models, excluding the baseline model. There wasn't a significant difference in RMSE values when 90 to 10 train to test data split was implemented instead of 80 to 20. These are some of the references. Moving on to the code. Print data.shape here tells us how many rows and columns are present in the data set, and data.d types gives us the type of data in every column. And this code checks for missing values in the columns. As the output suggests, there are two columns with missing values in them. Data.describe gives the summary of the data as seen here. And this code is part of the data exploration phase, which checks the frequency of categories present in the data. The data cleaning phase starts here as the missing values are imputed in the two columns. This is for the item weight, and this is for the outlet size. As you can see, the final missing values is 0, and the original values have all been imputed. This code checks if there are any null values remaining in the dataset after we have imputed the missing values. The feature engineering process starts here. As item visibility cannot be 0, as we discussed earlier, all the zeros are replaced by the average visibility of the product in all the other stores. Also, a broad category of item types are created here. From 16 item types to 3, we have reduced the number of item types. The data is split into 80 to 20 train to test data split using this code. There is a generic function which is that is being called by every algorithm that we have used. This saves a lot of time and effort, as you don't have to write the same code for every algorithm. This is the code for linear regression um, and Andridge regression. The RMSE values for both of them can be seen here. The decision tree with the maximum depth of 15, and then with the maximum depth of 8, and finally the maximum depth of 8, and finally the random forest regression model can be seen here, with initially a number of estimators set to 200 and finally set to 400 to check if there's any major difference in the RMSE values. So the decision tree model was found to be the best suited model for this data set, and ridge regression model was found to be the worst according to the RMSE scores. Thank you so much for watching this video.